my name is Simonne, and I did a project on hydrogen sensors. So hydrogen is vital for the future of clean energy. The goal of my project was to discover oxidizing agents that could be used with platinum nanoparticles to absorb hydrogen and release it as hydrogen ions in order to create an optical sensor. So I used 8 oxidizing agents in my original test and tested them by calculating molar concentrations and dissolving them in water and bubbling hydrogen gas in them. This first test suggested that potassium ferricyanide and potassium ferrocyanide would be viable for future experiments due to a slight color change. And so in comparison to the control group, so I had 2 groups. I had vials with the same concentrations, and I put hydrogen in one and no hydrogen in the other and compared the colors. And so the ferricyanide and the ferrocyanide showed a slight color change, but not really significantly. But we wanted to see if we could enhance this color change. So we decided to change the pH levels of the hydrogen to increase the visibility. This test showed that ferricyanide was best in detecting H2, and so I used the same procedure. And then my final test was aimed at determining the level of acidity that was most effective, so I used a buffer to better control the pH levels more effectively and added acids and bases. This test produced my final results that you can see here, confirming that acidic levels of ferricyanide at 6 or less had a visible change in color with the addition of hydrogen. So this is my group with hydrogen. This is 5 and 6, and then this is 7, 8, and 9. So 7, 8, and 9 are basic, and you can see that they didn't do anything. And this is my control group, and you can also see that they didn't do anything. And these are the acidic ones, and the addition of hydrogen really changed the color a lot. So I measured this color change by using a spectrometer to find the wavelength difference. So this is the 5 there. And this, you can see the peak absorbance rate, or units, is 560 is the wavelength. And so you can see that it absorbed more of the 560 wavelength compared to this one. And then this one is the comparison of the pHs, 5, 6, 7, 8, and 9. So you can really see on this one that the acidic levels really help to increase the amount of color change. The 5 was actually much bigger than the 6, which was kind of surprising because they look the same in the picture. And so my prediction for future experiments would be that more acidic levels of potassium ferricyanide would help to increase the color change. And this project can be used for future developments of hydrogen.